Hi, I'm Doug Hayhoe, and I've written a series of short video essays and podcasts on science, faith, and other topics. Most of the videos relate to one of God's two books, Nature or Scripture. This video is called Electric Vehicles, and it mainly relates to our use of nature. My summary is this. EVs compare well with ICE, internal combustion engine vehicles, in convenience and cost, but their environmental impact is much better. In 2018, we bought a Chrysler Pacifica hybrid van. It was the perfect vehicle for COVID when we only drove 45 kilometers a day, all on the battery. For longer trips, its gas-powered engine gave it a range of 750 kilometers. But in 2024, 6 years later, we sold it and bought a Kia EV9, totally electric vehicle. It's about the same size as the Pacifica, but its range is only 480 kilometers as it's an all-electric vehicle. So there you have a picture of the two cars beside our house there. And on the brick wall, you can see the charging mechanism we brought for the Kia on the right. This essay compares electric vehicles, which I'll use the term EVs, with internal combustion engine vehicles, ICEs, in terms of charging, range, cost, and safety. Our responsibility as stewards of God's creation, however, may be the most important reason to buy an electric car. Charging and range. North Americans are more concerned about the inconvenience of charging an EV and their relatively limited range than the cost. But if you install a high-speed charger at your house, you can comfortably charge the car overnight. That's also when the cost of electricity is at the lowest. If you live in a condo, as one of my EV friends does, you might be able to collaborate with other EV owners there and the condo board to install individual chargers in the parking lot. The cost of the installation may be more than a house version, but the cost of electricity may be comparable since condominiums probably get a preferred bulk rate 24/7. Not all condo buildings, however, have an electrical system capable of being easily upgraded. In Canada, a government website can help you with this. When you're on the road in an EV, it's usually easy to find charging stations close by. There are many apps like Charge Hub that identify locations of chargers of all types. Commercial charging stations may cost more than at home, but are useful for long-range trips. So there's one just around our house. Our house is the blue circle in the middle, and you can see all the charging stations within a couple of kilometers of our house. A friend recently drove to Florida and back with his Tesla Y. It took 20 to 30 minutes to charge his car at a charging station, which he did twice a day, at the Tesla supercharging stations, that is. Now, the Kia EV9 that we have is much larger and has a bigger battery, and also the charging stations it uses are slower than the Tesla supercharging stations. So my charging times will probably be double that, maybe even up to an hour. So when we go on a long trip, we'll need to stop for lunch near a charging station. The range of most EVs is still a good deal less than that of comparable ICE vehicles. I mentioned that our Pacifica hybrid had a range of 750 kilometers, but our Kia EV9 is only 480 kilometers. But while the fuel economy of an ICE in the city is much lower than in the country, gas-powered vehicle, the fuel economy of an EV is actually improves in the city. This is because EVs don't burn gas by idling. Also, whenever you brake, or as soon as your foot is taken off the accelerator, the battery is recharged by the semi-electric motor becoming a generator. This is called regenerative braking. Winter, however, gives a downside to EVs. Their range is not nearly as good as in warm weather. And there are two reasons for this. First of all, batteries don't perform nearly as well in the cold due to the reduced mobility of ions in the battery's electrolyte. Second, cabinet heat that you need in the wintertime is produced by battery power in an electric vehicle, while in an ICE car, the waste heat of the engine heats the cabin where you are. So here you can see an interesting comparison a friend of mine did over 3 years with his Kia Soul all-electric vehicle. The top graph shows the monthly average daytime temperatures. They go from 25 degrees Celsius in the summertime to close to zero in the winter over 3 years. And the bottom is the real range. He calculated the range. And you notice again, the range goes from his Kia Soul, it goes from 450, or a bit higher than 450 in the summer, down to about 300 in the winter. Interesting. Well, the same will be true probably of our EV9. It's by the same company, Kia. Now let's compare the all-electric Kia EV9 with a car the same size, the gas-powered Kia Telluride. Almost identical, these two cars. I've driven in them both. One's gas-powered and one's electric. You can choose two other very similar EV and ICE vehicles and the results should be similar. So the initial cost. So a new EV9, a Kia EV9, starts at $10,000 more Canadian than the Telluride. But there's a $5,000 rebate for EVs before Ontario's 13% tax is added. That's a federal rebate in Canada. So the extra cost is only $5,650 more. But then if you install a driveway charger, as I did, that may cost $1,350. So your initial EV cost is $7,000 more. Of course, if the government removes that rebate, then it's $12,000 more. The fuel cost. The Telluride has an average fuel economy of 12 liters per 100 kilometers. At the current cost of $1.57 per liter, this is back a year ago when I first wrote this, for gasoline in Toronto, this comes to $18.68 Canadian per 100 kilometers. So if you drive 25,000 kilometers per year, you're going to spend $4,670 on gas in an all-gas vehicle, the Telluride. Now, the electricity cost in Toronto for charging the EV9, on the other hand, is only 20% of this. I've worked this out in detail in the appendix to my written essay. So it will save you $3,736 per year, 80% of that gas cost it'll save you. It just costs you 20%. So you can pay off the extra purchase cost of $7,000 in 2 years. If you only drive 15,000 kilometers a year, you can pay it off in 3 years. If there's no government rebate, it might take 4 years to pay it off. A friend pointed out to me, though, that if you drive your EV for 10 years, the savings in fuel costs might recoup up to 50% of the initial cost of your car. At least they would help with any repairs that are incurred. Of course, electric vehicles don't yet pay for road construction. There's no tax on that, as there is tax on gasoline. This may eventually change as the number of EVs increases. Now, what about insurance and service costs? Well, auto insurance for the EV may cost more, as EVs are often more expensive to replace or repair when accidents occur, and our insurance rate sure went up when we bought the EV9. But insurance rates depend on many factors. On the other hand, service costs will be less, as EVs require no oil change or lubrication, and often there are no routine service visits. In fact, we've almost had our car for a year now, our EV9, and made very few, maybe one visit. With regenerative braking, which I mentioned earlier, one driver said that he saved $600 a year on brakes alone. Another only paid $140 per year for several years to service his EV. What about depreciation? In their early years, EVs lost value more quickly than ICEs, partly because their range was so small. But today's EVs have better batteries and longer ranges, and eventually they may hold their value as much as ICEs, although right now in the current climate in the United States, that's probably not true. But over the years, I think that's true. Safety. When a cousin who is a fire chief saw my Kia EV9, he noted that fires in EVs are more difficult to put out than those in ICEs. The fire burns from section to section of the battery throughout the entire car. But a recent report from Auto Insurance EZ, however, said that EVs had 60 times fewer fires per 100,000 sales than ICE vehicles. And my cousin, in the long run, the fire chief, said that he might still buy an EV. Another safety issue with EVs was the risk to pedestrians because they're so quiet, according to a recent report. But the data for this report was from the UK a decade ago, and the research has been questioned as to whether it has any significance for us today. In the past few years, laws have been passed to mandate at least 30 decibels of sound to be produced and a louder sound for reversing an electric vehicle. What about the efficiency and environmental impact? Well, ICEs, gas-powered cars, have a theoretical efficiency of only 50%, compared with 100% for electric vehicles with regenerative brakes. Now, ICEs also have up to 2,000 moving parts, while EVs only have 18 moving parts. In fact, the total conversion efficiency of fuel energy into kinetic energy for an ICE vehicle powered to wheels is only really between 16 and 25%, whereas for electric vehicles, it's 86 to 90%. There you can see two diagrams comparing the 2,000 parts in a gas vehicle with 18 moving parts in an electric vehicle. The biggest advantage of the EV over the ICE car, however, may be its environmental impact. Cars and vans account for 10% of the global carbon dioxide production, although the total transportation sector, including airplanes, trains, and trucks, accounts for double this amount. And this is a main driver of climate change, one of our most serious threats. You can see my video and essay called The Science of Climate Change. Gas-powered cars also emit volatile organic compounds, hydrocarbons, carbon monoxide, ozone, lead, and various oxides of nitrogen. Also, their brakes release much more brake dust. When you take your foot off the accelerator in an electric vehicle, as I've mentioned, the electric motor switches to become a generator and you hardly have to use the brake at all. Electric vehicles can often be driven using one pedal only. I hardly ever use the brake pedal in my electric vehicle. People point out, however, that the mining of the rare earth minerals used in lithium-ion batteries, such as cobalt and nickel, can damage the environment, which is true. But the Wall Street Journal has noted that the Chinese have developed a way of refining cobalt and nickel out of industrial waste. And in the United States, there are companies such as Ascend Elements, the name of a company, which is an independent manufacturer of advanced battery materials using valuable elements reclaimed from spent lithium-ion batteries. So recycling is saving a lot of that waste. Another objection to electric vehicles is that the production process of making an electric car and its battery may produce more carbon dioxide than that produced by making a gas-powered vehicle. However, MIT has a climate portal, and it's looked into this. There's some research showing that in the end, battery-driven cars have much less impact on the environment. For additional recent reports on this topic, you can look at Scientific American or another journal, The Conversation. A further objection to EVs is this. Canada may have ambitious timelines for moving us all into electric vehicles, but does it have realistic timelines for increasing electrical production from utilities powered by non-fossil fuel sources to support the increase in electric vehicles? You can see a link on my written essay for an overview of Canada's energy sector. Many people not yet convinced by the environmental impact argument, such as another friend of mine, still enjoy their EVs for other reasons. This friend has bought Teslas for 12 years now because, as he says, they are fast, nimble, and quiet. However, I still hope to persuade him that in the long run they are also better for the environment than the ICE vehicles. Conclusion. In terms of convenience and cost, EVs and ICE vehicles may be about even. But many people are seriously concerned about the greater damage that ICE vehicles cause to the environment. They love this wonderful earth that we live on, and they want to see it remain the same for future generations, including their children and their grandchildren. And they see the purchase of an electric car, as well as other lifestyle changes, as one way to save it. But if you're a Christian, you have a further motivation. The Bible has many references to the stewardship responsibility God has given us with respect to our natural resources. The famous scientist who invented the electric motor and the electric generator 200 years ago, Michael Faraday, was a very faithful Christian who was very concerned about the environment. Here's a picture of Michael Faraday. You can read my essay, my video on him, Michael Faraday. For other resources and references about electric vehicles, see my text essay on this website. Thank you for listening.